This is Mr. Martin. These are the video notes for section 6.1, Law of Sines, Day 2, Video 2 for Pre-Calculus Honors. So we've already looked at examples where we had side-side angle cases where it turned out to be a one triangle case, and one example where it turned out to be a two triangle case. So let's take a look at a problem where there's actually no triangles. So normally I'll just set up a triangle, and then let's label what we have. So I have side A is 2, side C is 1, and angle C is 50 degrees. So I see that I have a side-side angle case. And normally what we'll do is we'll just pretend that there's two triangles, and then as we work through it we'll find out if there's one triangle, and in this example we're going to find out what happens if there's actually no triangles. So I've got side C is 1 and angle C is 50, so I should be able to find the side of A, angle A. So sine of angle A over 2 is equal to the sine of 50 degrees over 1, and then the sine of A is going to be 2 sine 50 over 1. And I'm doing it like this just to show you. If I calculate this, I'm going to get that 2 sine 50 over 1 is 1.532. So then in order to find A, I would do the sine inverse of 1.532. And if we think about this, sine inverse says that we're looking for an angle whose y-coordinate is 1.532. Well, there are no angles on the unit circle that have a y-coordinate larger than 1. No angle has a sine greater than 1. Okay, so what this tells us is therefore there is no triangle possible with the given information. Okay, and if you went ahead and you plug this into your calculator, you're going to get some sort of an error. The newer calculators will say there's an error domain, or you'll get some other message indicating that you can't take the sine inverse of a number larger than 1. Okay, so that's our third example, no triangle possible. Moving on to the last topic for this section, we're looking at the area of an oblique triangle. We know the area is normally 1/2 base times height, and it's a pretty straightforward derivation to come up with this formula, but it's really coming from 1/2 base times height. The information that we need, it's the length of two sides of the triangle and the measure of the included angle. So it's important that it's the included angle. So for this first example, we could also have here 1/2 BC, and then the included angle would be angle A, so we could have that as well. But basically it's two sides and the included angle. Substitute everything into the formula. So we have a triangular lot, and I've got two sides that are lengths 24 and 18, and the angle between the two sides is 102. So for this example, we have all the information needed to find the area. If I didn't have an included angle, or I needed to find another side, we could use whatever methods we needed to, for example law of sines, to get two sides and the included angle. So now the area is simply going to be 1/2 the product of the two sides, so 24 times 18, times the sine of the included angle. The angle has to be in between the two sides like it is here, and we get about 211.28 meters squared. Okay, if units are given in the problem, make sure you include them in the answer. Again, if you have any questions about these two examples or you want to talk about the derivation of the formula for the area of a triangle, make sure that you ask me next time you see me in class. And we will see you in the next video.